about mirror neurons and aggression. So, to begin, I need to explain the acronym VLVMH or VMHVL. It doesn't really matter. It's just a part of the brain called the ventral medial nucleus of the hypothalamus. You don't need to remember that. Just VMHVL. That's just a part of the brain where these neurons are. And what's interesting is that mirror neurons are something that people have recently discovered, where there are neurons in our brain that not only activate when you act on something, for example, if you throw a ball, right, they activate, but also when you see someone else throwing a ball, the same neurons will activate. That's why they're called mirror neurons, because they activate when you see them, you see an action, and you also partake in the action. Translate.
大家 continue.
So people have found out that when you inhibit these neurons in mice, so you could stop them from activating, or you lower the amount of activation, it reduces the amount of aggression that mice exhibit. So the study wanted to see if it not only happened when, that not only inhibits the aggression of themselves, or they want to see if these neurons activate when they see other mice acting aggressively. And I'll show pictures so it's more clear. Okay, so here you can see a diagram of a mouse observing fighting and these neurons activating. And these are the same group of neurons that activate when they act aggressively themselves. So when they're in a fight, these neurons activate. And here, so the method that they used is interesting to see neuron activity. They took, it's a process called fiber photometry, which is an imaging technique that uses the fact that when your neurons are active and neuron activity is, there's neuron activity, there's an increased level of calcium. And basically they use these calcium indicator proteins, or they're genetically encoded calcium indicators that change their fluorescence, so their color, to match the specific amount of, to match the amount of calcium. So that's how they can see it. And you'll see the pictures and it'll be a lot more clear. But then after that, the systems, so the machines actually send a wavelength of light that excites these indicators, and then they send a signal back, and that's how we see the activity. So let's talk about the setup of the experiment itself. There's a male mouse, the intruder, who is introduced to a male mouse inside of a cage. That is the resident. And there is a transparent wall where another mouse, the third mouse, the observer, is watching through this wall of a transparent wall. So they can see all the action, but they can't get in on it, they can't fight. And there are they tried two different ways. So first of all, they had holes so the pheromones could get through, but then they closed off those holes and put a roof on them so that there were no pheromones. And here are the results. So you can see here that they were only activated when witnessing tail rattling is basically a mouse way of being aggressive. That's saying that, oh, I'm going to attack. It's threatening another mouse. When they witness that, they activate it, but they don't activate. So you can see the blue. That's the when it's red or it's higher in the spectrum. That shows activation. They did not have this activation when they were watching mice do other things like grooming, running in their wheels or other displays, and they didn't show, or chemo investigation even, which is when they go sniff another mouse, right? But they do activate when there's a very clear and high amount of activation, when they are attacking themselves. So this is the top parts are the measurements of the mice that are attacking, but it is the same. There's a lot of activation also on the observer. So the mouse that is seeing the mice, the other two mice attack and fight, also have increased increased levels of activation in the VMHVL PR neurons. So they wanted to find out whether this was just something that they saw and they knew and they immediately began to fight. It was something they see to process, or if it's pheromones. So they turned off the lights, or not they turned off the light, but they used the illumination, infrared illumination, because mice can't really see in that. And when they did that, there was no activation. And when the mice were facing away from the fighting, even though it was happening when there was normal light, there was also no activation. So yeah, this is when it's infrared. You can see that it's all mostly dark blue, and that is just what I talked about earlier with fiber photometry. That's the fluorescence, like a lack of a lot of activation. So this is the most interesting part to me, right? Is it something that they know instinctively when they're born, kind of like a primal instinct, or do they learn and they've seen fighting before and then it activates? So they have the naive mouse, the naive observer, who has never had, they're not socially experienced. They're not sexually experienced, and they're not they've never seen aggression. So that's the naive observer. And what is so interesting about this study to me is that the naive observer actually has activation as well, despite having never seen fighting in their lives. And not being a part of the fighting, there is the activation of these neurons. So that is like an indication of the fact that it's not learned, it's almost like intrinsic. And okay, so they tried inhibiting these neurons, right? And that causes significant reduction in the amounts of times the mouse that's fighting, or supposed to be fighting, initiates attack. And what the crazy statistic is the time spent attacking the intruder was reduced over 10-fold. And this is when you forcibly activate these neurons. It becomes a lot more aggressive. There are more tail rattling, and what's crazy is that there's even tail rattling and attacking of female mice instead of the typical behavior, which would just be they would take the pheromone cues and then try to mate with the other mouse, but it attacks the female mouse when the VMHVL PR neurons are activated, forcibly activated. They even attacked, or they even threatened their own reflection in the mirror. So to recap, VMHVL neurons are mirror neurons that activate not only in the act of aggression, but when witnessing aggression. So they are the mirror neurons of aggression. And the activation works through sight. They don't need to be socially experienced to have this activation. So they can go their whole lives without ever seeing a fight, but they would still have this activation. And inhibition of these causes reduced aggression, while forceful activation causes increased activation. So what I really thought was interesting about this research, and kind of how I applied a bit of AI, is through, I'm sure everyone is very familiar with ChatGPT. So I was kind of thinking of a medicinal purpose of this study, and I asked ChatGPT what it thought about a drug or some kind of neuromodulation, some way of inhibiting these neurons in people who have aggressive tendencies, in humans, right? Who have anger issues, who maybe they're yaba, or they have very right, ways of rehabilitating people who have heightened amounts of aggression. maybe if you have like a drug that inhibits it, you know, that would, like, it could have like an effect. And the response ChatGPT gave was interesting, very long, explained kind of how, I think what the main takeaway was is that research has potential, but there also has to be infinitely more like research into it to be certain. So I think like how I interact with like these kind of chatbots and like what I really like take away from them is kind of like, I like to pitch them research ideas and kind of like medicine ideas to kind of see if it's feasible from, or at least from the perspective of them. Like with my research at UBC, I also asked like whether it thinks this area needs more research, and it, by the way, it did say yes. So it kind of reinforces my motivation. So yeah, this is my presentation on mirror neurons and aggression.